So today's video is about converting fractions and decimals. So what does it mean to convert? Well, converting means that you change from one thing to something else. For example, if I convert forms of matter, I may change water from a liquid to a solid by putting water in the freezer to make ice. Therefore, the water converted from a liquid to a solid. But even though it's gone from a liquid to a solid, it's still water, it's just in different forms. So numbers can convert as well. They can change between fractions, decimals, and percents, just like water can change from a liquid to a solid to a gas. So how do you convert or change a fraction to a decimal? Well, you simply divide the numerator by the denominator. And how do you convert or change a decimal to a fraction? Well, the first step is the number behind the decimal is the numerator of your fraction. The place value of the last digit is your denominator, and then simplify your fraction. So let's change this fraction or mixed number to a decimal. So let's start with 5/8. So what I want to do is I want to convert 5/8 and change it to a decimal. But I'm not changing the value of the number. It's still going to be equal to the same thing. It's just they'll be in two different forms. One is in fraction form, but one is in decimal form, but they actually equal each other. So I'm going to divide the numerator by the denominator. The numerator always goes inside the house. So your top number goes in the house. So I'm going to put the 5 inside and the 8 outside. So now I'm going to go ahead and start dividing. And we learned in our decimal unit how to divide. So the first thing I'm going to divide is 8 into 5. But 8 can't go into 5, which means I have to add a decimal and a 0. And I'm going to bring that decimal up on top of the house. So when I bring that decimal up, now I can divide. So now I'm going to divide 8 into 50, and it goes in there 6 times. So 6 times 8 is 48. I subtract them, and I get 2. I don't have 0 yet, so I can't be done. I have to add another 0 under the house, bring it down, and then start over. So now I'm dividing 8 into 20, and it goes in there 2 times. 2 times 8 is 16. Subtract, and I get 4. Again, I don't have 0 yet, which means I'm not done. I have to add another 0, bring it down, and start over. So now I'm dividing 8 into 40. Well, it goes in there 5 times. 8 times 5 is 40. Subtract, and I get 0. Now that I have 0, now I can stop, and I have nothing left to bring down. So 5/8 is equal to 625 thousandths. And we call this a terminating decimal, which means that when I change the fraction to a decimal, there was a stopping point. It actually stopped. And you'll see in the next example the difference between a terminating and a repeating. But this is a terminating decimal. It did stop. So now let's change a mixed number to a decimal. So when I have a mixed number is made up of a whole number and a fraction. Well, when you have these mixed numbers, you have to kind of separate them. The whole number is going to remain a whole number, and it's going to be the number in front of your decimal. So this 2 is going to stay a 2. It's just going to be in front of the decimal. The 1/5 I do need to change to a decimal, just like I changed the 5/8 by dividing the numerator by the denominator. So 5 is going to go outside, 1 is going to go inside. Again, I can't divide 5 into 1, so I'm going to add that decimal and 0 under the house. Bring my decimal up, and then divide. So I'm going to divide 5 into 10, and it goes in there 2 times. So then 2 times 5 is 10. I subtract, and I get 0. So I have nothing left to bring down, and I'm at 0, so that's the end. So that means the number behind my decimal will be 2/10. So then my 1/5 is equal to 2/10. So that means my final answer is 2 and 2/10. So 2 and 1/5 is equal to 2 and 2/10. The whole number was in front, and then the fractional part is behind. And again, this is what we call a terminating decimal, because when we divided, it stopped. There was a point where it stopped, and we were done. So now we're going to look at what are called repeating decimals. And you're going to see as we go through the example how this is different from the example we just did. So I want to change 1/3 to a decimal. So again, 3 is going to go outside, 1 is going to go inside. I'm going to divide 3 into 1. It can't go in there, so I have to add decimal and a 0. I'm going to bring that decimal up, and now I'm going to divide 3 into 10, and it goes in there 3 times. Well, 3 times 3 is 9. I'm going to subtract, and I get 1. I'm not at 0 yet, so I have to add a 0, bring it down, start over. So now I'm going to divide 3 into 10. It goes in there 3 times. 3 times 3 is 9. I subtract, and I get 1 again. But I'm not at 0 yet, so I add a 0, bring it down, start over. So now I'm dividing 3 into 10. It goes in there 3 times. 3 times 3 is 9. Y'all see what's happening here? And subtract, and I get 1. So again, every time I seem to do this problem, I keep getting 1 when I subtract, and I keep putting 3's on top of the house, which means that I have what's called a repeating decimal. When you realize you have a repeating decimal, you can stop, because the question or the problem is not going to stop. Repeating decimals go on forever. If I were to do this problem for another 10 minutes, I would still be getting 3's on top of the house. So once you realize that you have a repeating decimal, you can stop. So then my answer would just be 3/10. But because the 3 is a repeating 3, I'm going to put a bar above it. So that makes it a little different than just a regular 3/10. It means that this is 3/10, but that 3 is going to keep repeating over and over and over again. So let's look at another one. I have 6 11s. So again, I want to divide that 11 into 6. 11 can't go into 6, so I have to add a decimal and a 0. I've got to bring that decimal up and then divide. So now I'm going to divide 11 into 60, and it goes in there 5 times. So 5 times 11 is 55. Subtract, and I get 5. I'm not at 0 yet, so I'm going to add a 0, bring it down, start over. So 11 goes into 50 4 times. 4 times 11 is 44. Subtract, and I get 6. Again, not at 0 yet, so I'm going to add a 0, bring it down, start over. 11 goes into 60 5 times. 5 times 11 is 55. I subtract, and I get 5. Again, add a 0, bring it down, start over. 11 goes into 50 4 times. 4 times 11 is 44. Subtract, and I get 6. So if you'll notice, this time I keep getting a 5 and then a 4 and then a 5 and then a 4. And if I continue on, I'll keep getting 5, then 4, 5, then 4. So really, when I realize it's a repeating decimal, I can stop. So my answer would be 54 hundredths, but I'm going to put a bar above the 5 and the 4 because both numbers are repeating. So whatever is repeating is what you put the bar above. It could be one number that's repeating. It could be 2. It could even be 3 numbers that are repeating. And then you have some situations where one or two of the numbers don't repeat, and then you have a third number that is repeating. So you only put the bar above the number that is repeating. So that's the difference between a repeating decimal and a terminating. Repeating decimals go on forever, and it keeps repeating, and then a terminating decimal stops. So now we want to look at how we're going to change a decimal to a fraction. So in the notes, I told you that you're going to basically look at the number behind the decimal. That's going to become the numerator of your fraction, and then the place value of the last digit is going to be the denominator. So when I look at this number, the last digit is in the 10th place, so that means my denominator will be 10. And then my number behind the decimal is 7, so it's going to be my numerator. So then it would be 7/10. And if you actually say this number out loud, you can actually hear the fraction. If I were to read this, I would read it as 7/10. And so here I have 7/10. And then 7/10 is in its simplest form, so I can leave that. So then if I look at this number is 25 hundredths. So that means my number is in the hundredths place, so my number has to go over 100. So I'm going to put 25 over 100. And then this is not in simplest form because 25 and 100 can both be divided by 25. 25 divided by 25 is 1, and then 100 divided by 25 is 4, so then my simplest form is 1/4. Sometimes you will have a number in front of and behind the decimal. In that situation, that means you're actually going to have a mixed number. So the number that's in front of the decimal is going to remain the same, and it's going to be the whole number. And then the number that's behind the decimal is going to be my fraction. So now I'm going to have a mixed number, a whole number and a fraction. And if you'll notice, the 4 was in front of the decimal, so it was my whole number on my mixed number. The 4 is still a 4. And then my number behind the decimal is 5/10. So I have to show that in fraction form, 5/10. And then, of course, simplify. Well, 5/10 can be simplified to 1/2. So then my final answer is 4 1/2. So as you're doing these problems, one of the things that you definitely want to remember is that the numbers are still equal. Even though you're changing a fraction to a decimal or a decimal to a fraction, the value of the number is still the same. It's just in different forms. You also want to make sure that you remember when you're dividing a fraction, the numerator goes inside the house, the denominator goes outside the house. All right, go ahead and teach the tiger something that you learned in the video today.